Hello, this is question 9 on your June 2018 paper 3 from AQA. You have this curve. We have to prove that the curve does not intersect the coordinate axis. So we are going to try to find the points of intersection. So when x is 0, we have 0, 0 equals 12. That cannot be. And when we try to make y equals 0, again we have the same situation. 0, 0 equals 12. So this is not possible. And it's not possible, there are not points of intersection. Then the B, it says, show that the derivative is this one. So we have very mixed x and y together, so we are going to use implicit differentiation. To differentiate this, we are going to do 2 times, so it's a product, so I'm going to use the product rule. 2 times x y squared is my first term, so I derivate the first one and multiply by the second one. Then I do the other way around. I leave the first one and derivate the second one. And this is where I'm going to use implicit differentiation. So derivative of y squared is going to be 2y, but now I'm going to multiply by dy by dx. And I'm going to do the same with this second term. It's a product, so derivative of the first one, which is 1 times the second one, plus the first one, derivative of the second one. So 4x cubed dy by dx. Sorry, this is y cubed. And this is equal to 0. Yeah, and now I just make dy by dx the subject, so I can put them together, dy by dx, multiplying x squared 2y, I'm going to order them, 2y x squared, and plus 4y cubed x, equal to minus 2x y squared minus y to the power of 4. I'm just factorizing these two terms and putting these two in the other side. And that means that dy by dx is going to be minus, I can write that minus at the front, I think they do that. Yeah. 2x y squared plus y to the power of 4 divided by 2y x squared plus 4y cubed x. And if you notice, we can cancel y's, so we can cancel this one, 3, this one, and 2. So we have minus 2x plus y cubed divided by 2x squared plus 4y squared x. Yeah, that I think is what we need. Yeah, it is. Yeah, so it's this expression. Then the second part says prove that the curve has no stationary points. Stationary points come from making this equation equal to 0, which could means numerator equal to 0. So stationary point is dy by dx equals 0, which could mean numerator 2xy plus y cubed equals 0. If we factorize, we have y 2x plus y squared equals 0, could be, or y equals 0, and we have proved in part A that that cannot be, but we don't have intersection with the axis. Part A, not possible. Yeah, not possible. And the other option is that 2x plus y squared is 0, and that cannot be because then y squared could be minus 2x, and again not possible because there is a square root of a negative number. Minus 2x, not real number, yeah? Then the last part, it says, in the case when x is positive, find the equation of the tangent to the curve when y is 1. So when y is 1, we are going to find the gradient and we are going to find the x, yeah? Because if we need the equation of the tangent, we need the gradient and the point. We can start with I'm going to start finding x because I will need x to find the gradient as well. Yeah. So when y is 1, I go here to find x. So third part is when y is 1, to find x, I'm going to substitute here the y by 1. So I have x squared plus x equals 12. X squared plus 12. No, sorry. Plus x equals 12. X equals 12, which means x squared plus x minus 12 is 0. So if I factorize, I have x minus 3x plus 4. So one solution is x equals 3, and the other one is x minus 4. But they say use the positive 1. So when x is positive, so that's the point, and now I need the gradient. So the gradient, just substituting there, gradient of the line is going to be minus, and I'm just going to substitute the x by 3 and the y by 1. Yeah. Do I have it here? No. So 2xy cubed. I'm going to copy the thing before we substitute. And 2x squared for 2x squared for xy squared. Yeah. I'm just going to substitute. It's going to be when x is 3 and y is 1. Yeah, I'm going to substitute that. I have minus 2 times 3 times 1 plus 1 divided by 2 times 3 squared plus 4 times 3 times 1 squared, which is minus 7/30. So the equation of the line is going to be y minus the 1 of the line is the gradient, brackets, x minus the x of the line. Yeah, they don't ask us to write in a particular way. No. So if they don't ask us to write in a particular way, you can leave like this. You can multiply by 30 and expand the brackets, but it's not going to look much better anyway. Yeah, because of the denominator. And the 7 is not nice numbers. Yeah, so I would just leave it like this. That's all.